And welcome. This is Andy and Ian Talks Networking. I am Andy.
And I'm Ian.
Hello, everybody. And today's topic, we've been taking some feedback from the field and from people responding on LinkedIn and direct messaging me. And today we're going to talk about a really interesting subject, which kind of confuses a lot of people. But really, what we're trying to do is to understand, are all packet brokers built equally? And this is an interesting subject from my perspective because, again, I came to this from a different industry to a certain extent. And when I started learning about packet brokers, and we talked a little bit last time, if you remember, Ian, about tapags and
Yeah.
packet brokers, and kind of I was trying to understand a little bit about why wouldn't everybody just build the same type of product? Why don't we just build a packet broker that we can put in our network and we can monitor all the traffic, and hey presto, everybody's happy. And when I look around and I look at different products and features and things like, there's a lot of numbers that get thrown around, and it really kind of confused me a little bit about what makes one packet broker different to another packet broker. So I think that's kind of the discussion I think we probably ought to start with today. So let me ask you the question: are all packet brokers built equally?
No, they are not, Andy.
Okay,
They
that's
are
the end of that then.
absolutely, yeah, exactly. That's the end of that. No, it is a really big question that many customers, prospects, people who are familiar with the industry, people who are coming in fresh, like yourself, so to speak, maybe they come in from a different team,
Hmm.
etc., and they're like, well, hey, this is a packet broker, this is a packet broker. Well, they're the same, right? And I think that if you go way back in the day, um, even in the switching days, the idea of one switch being just like another switch, I
Yeah.
think you would find the vendors were pretty much against that kind of thinking. And I think you can say the same pretty much today, that they are pretty much fundamentally different often,
Hmm.
and it's really important to think about the trade-offs and the architectures for designing your system. Not what suits cPacket necessarily, but what suits your environment, what suits what you're trying to do with your applications and your network.
Okay, yeah. So what do they actually do then to kind of make the differences between the different products? So, if I were to take a packet broker from vendor A and a packet broker from vendor B and vendor C, and they may be similar or major difference in pricing, what are they doing that's different between the different vendors that really justify kind of the changes and the positioning of those products? Is it
Well, so
architecture, or is it just like I'm using a cheaper chipset?
no, it's really the fundamentals of what's going on inside the metal box, so to speak. Bottom line is that you all bit of a big claim. Generally speaking, I've found that all packet brokers are using some kind of core standard Ethernet switching
Yes.
capability in
Yeah.
the center,
Okay.
right? Multiple vendors, but bottom line is they're using some kind of standard Ethernet system. So it looks in some sense like a switch,
Hmm.
right? That you would be buying from a switch vendor, but they are not switches. And then you've got effectively a layer of software, which is giving also an additional layer of kind of uniqueness or something that's adding value more or less to
Hmm.
that product that is being provided. And then you get to the real meat and potatoes. Effectively, how do you enable, with that core switch in the center, how do you enable those software capabilities?
Yeah.
You can either use a look-aside, a bit of an odd term, but effectively connecting a CPU
Yeah.
to the switching chip, PCI,
Some
some kind of
sort of high
interface,
speed connected interface, something like that. Yeah.
high-ish
High-ish. Yeah,
speed,
exactly. Yes. Yeah, yeah. I mean,
high-ish
and,
speed
and I
interface.
remember in the old days they used to just take one of the SGMI ports off the side of the chip. And yeah, yeah.
Yes, I think you just dated yourself just a
Yeah, I'm an
teeny
old
bit
guy.
there,
Yeah,
Andy.
I can go up
But
to
but
MII, but anyway.
but yeah, exactly. That's exactly the idea. You connect it with some kind of a high-speed interface, or you have that same CPU, possibly with an even extra FPGA or a couple of FPGAs running on the site.
Right.
Now, that allows you to have software flexibility in one sense, but it obviously has that quite limited bandwidth connection
Right.
between the
Yeah.
switch and the CPU. I don't think we're using SGMI anymore, but yes, the idea that there's some kind of interface.
Okay.
Now, obviously, cPacket, we're from cPacket. I appreciate we're trying to present both sides here, but bottom line is with that, with the NG boxes that we put FPGAs behind every port, so you
Right.
don't have that look-aside
Right. And
concept.
in fact, they're in line, so the packets go through every single one of those versus it being broken out.
Yeah, absolutely. So that kind of is a fundamental difference. So you get the same software value, obviously, but you're doing that all on every port with every bit of every
Yeah.
packet, and then going through that kind of standard switching architecture, and then being sent on to a broad range of tools, security otherwise,
Yeah.
for your requirements. So really, the fundamental difference is how you imagine
Joining
that
things up. Yeah.
connection between the switching silicon and some kind of management infrastructure, possibly with an FPGA. Obviously, it's
Yeah.
not just all about the CPU. There are other tools out there as well, or other chips. But the question is, as soon as you introduce that bottleneck, you're going to get tripped up. And
Yeah.
that's really the key point. If performance is key, and actually you really want to move those packets and do all of the time stamping and do all of that stuff so that you really understand exactly what's going on, you're going to need to do something a little different. And that's what
Yeah.
cPacket is trying to do with its NG
So,
family.
so I guess when you look at it, kind of from an architectural perspective, the side approach has advantages. Obviously, it's cheaper, it's easier to connect, software encoding, those kind of things. But the downside is obviously, as you said, you end up with performance. How fat is that pipe between the switching logic and your CPU or your ASIC that's on the side of the switch? Presumably, you also have feature problems because you're now feeding 32, 64, 128 ports of X bandwidth data in through that side interface. You may run out of bandwidth, your CPU may run out. So I assume you probably come up with things like oversubscription problems where you're trying to feed too much data into the broker and the side hosted CPU can't handle it, or the ASIC on the side can't handle that,
Yeah.
as well as
Uh,
latencies and various other problems. So you end up basically
yeah.
dropping packets.
Yeah, no, absolutely. I think also that it's just to be fair, I don't suppose people are assuming that they're running their network at 100% load all
Sure.
of the time, right?
Yeah.
That was probably not a very good architecture. The trick is to understand from your vendor, whoever your vendor is, what is the amount that you can have on each port
Yeah.
before you start losing packets or the possibility of losing
Yeah.
packets. And the other question really is not just about losing packets, it's whether if you want to do multiple
Yes.
smart air quotes
Functions. Yes.
capabilities,
Yeah.
do you need to go round again, so
Hmm.
to speak? And if you're on a round again kind of style architecture where I do one feature, it then comes back, and then oh, I want to do a second feature, it has to go again.
You've now halved your
Clearly
bandwidth.
that's you've halved it
Yeah.
again,
Yes.
and that would be a huge concern
Yeah.
in terms of how much performance you're really trying to make
Yeah.
sure you have for the tools that you believe are critical for your infrastructure, for your observability needs
Yeah.
in your
No,
network.
that makes a lot of sense. And I can definitely see, in a situation, but to a certain extent, you don't want to have to kind of confine yourself. If you can get a broker that can deal with all ports at full line rate, that just takes a lot of the management and issue problems off of your deployment. And now you're no longer in a situation where you have to think, is my packet broker oversubscribed? And I'm
Yes.
not now seeing the problem that an undersubscribed packet broker would easily be able to capture. Yeah, that makes
Yeah,
a lot of sense.
100%, Andy, 100%. I'm sure we've only touched on half the
Yes.
topics here, and I know we're probably out of time already.
Yeah.
Bottom line is, this is definitely an area I'm super happy to talk to anybody about, and we probably will try and do a couple of follow-on videos. Please put them in the comments below. Let us know how to best answer your questions, and we can go from there.
Yeah, no, I think you're right, and I think key thing for everybody here is the architecture does make a difference in packet brokers. There's absolutely no doubt about it. All the features we're talking about, from oversubscription and inserting and modifying packets, deep packet inspection has a huge impact on the way that your packet broker is architected. So
Yes.
you're absolutely right. I could definitely see, as you look at the way the different products from different vendors are implemented, there's definitely a lot to discuss, and a lot more we can discuss in many discussions going forward. So with that, I think we'll finish it there. Thank everybody for their time. I would like to just remind everybody to please like and subscribe if you've enjoyed Ian and myself's content. And as I said, this has been Andy and Ian Talk Networking, and we'll look forward to seeing you again next time. Thank you.
Bye for now.